Today's video is going to be about molar mass and a little review about how to find molar mass of elements and compounds. So the definition, molar mass is the mass of 1 mole, of any substance. When you got 1 mole of something, that's going to be a molar mass. And we use this generally just in chemistry when we're talking about molecules or compounds or atoms, because 1 mole is 6.02 times 10 to the 23rd of anything. So it's a really big number. So generally we just talk about molar mass when we're talking about much smaller things. And to find the molar mass of an element, it's really, really easy. We could just take an element like nitrogen. So nitrogen would be N, and we would have to find it on the periodic table. And the molar mass is exactly what we see down here. So the molar mass of nitrogen is about 14 grams per mole. That means if I had 14 grams of nitrogen atoms, that would be 1 mole, or 6.02 times 10 to the 23rd atoms of nitrogen. So we could do a few more, and all we're looking for is what's on the periodic table. So if I picked an element like helium, we would find it right up here. And that's about 4 grams per mole. So if I had 4 grams of helium, that would also be a mole, because helium is a much lighter atom than nitrogen. I don't need as much mass to have the same number of atoms. We'll do one more. We could take a look at maybe aluminum. So Al, all we gotta do is find it on our periodic table right here. And it'd be 26.98. We could round that up to about 27 grams per mole. So that's how we find the molar mass of just an element. But when we're finding the molar mass of a compound, such as H2O or water, it's a little bit more difficult. So for water, we got 2 hydrogens here and 1 oxygen. And what we have to do is we have to add the mass of each atom up. So the way I like to show my work here is I have both my elements, hydrogens and oxygens. I have 2 hydrogens because of the subscript. And when you don't have a subscript, you got 1 of those. So I got 1 oxygen. And each hydrogen, if I take a look at my periodic table, has a mass of 1 gram. From right here, and each oxygen has a mass of 15.999. We'll call that 16 grams. I'm multiplying here because if I have 2 hydrogen and each one weighs 1 gram, the mass of all my hydrogen would be 2. And I have 1 oxygen, it's 16 grams. The mass of my 1 oxygen would be 16. And my last step here is I got to figure out the mass, how much it weighs on Earth. I would add these 2 together, and my answer for molar mass of water would be 18 grams for 1 mole, which means if I have 18 grams of water, 18 grams of H2O, it would be 1 mole. So let's do another short example here. Let's say we had a molecule like this. So this is 1 carbon. So we got, I'll write it on a new paper. We got 1 carbon and 4 hydrogen. This would be methane. And to find the molar mass of this, I'd write both elements out, carbon, hydrogen. I only have 1 carbon here. And I got 1, 2, 3, 4 hydrogen. If I look all around, the mass of my carbon would be right here. It's about 12 grams. And the mass of 1 hydrogen, we did this from the last problem, is 1 gram. So all of my carbon, because I only have one, would weigh 12 grams. And because I have 4 hydrogen, I got to multiply it by 4. So that would be 4. And my last step, because I got to figure out the mass of this whole molecule, I got to add them together. And CH4 would have a molar mass of 16 grams per mole. So if I had 16 grams of CH4 or methane, that would be 1 mole of molecules. We'll go through a couple more examples here. Here is carbon dioxide. So that would be 1 single carbon, just 1 carbon, and 2 oxygen. And we know from previous problems, carbon has a molar mass of 12, and these oxygen are each 16. So that 1 carbon would weigh 12 grams. These 2 oxygen, 16 each, 2 times 16 is 32. And if I have to add their masses together, because they're in the same molecule, my answer would be 44 grams per mole. We'll do one last example here. We'll do one with 3 different elements in it. All right, here is an example of what acetone looks like. And you can see when the larger the molecule is, the longer these questions take. So we got, our formula would be C3, H, 1, 2, 3, 4, 5, 6. And we just got 1 oxygen. So I can write each of these down. C, H, O, the amount we have of each, 3 carbon, 6 hydrogen, 1 oxygen. And each carbon from our periodic table has a mass of 12 grams. So all 3 of them together would contribute 36 grams to this molecule. Each hydrogen weighs 1 gram, so all 6 of them would contribute 6 grams to this molecule. And just my 1 oxygen on top, 16 grams to this molecule. And my last step, because I'm figuring out the mass of all of them together, I need to add all of them for an answer of 58 grams per mole. I hope this helped a little bit if we were having trouble with molar mass, and it could also help us with the start of those mass to mole or mole to mass conversions as well, because we got to do this as a step in those questions.